I still believe that supervised learning is an incredibly efficient way to make use of compute and parameter capacity in a deep neural network. But that does not imply that I don't believe in reinforcement learning, which is improving a system from interaction and feedback.
Right.
Then the question is like, how do you implement reinforcement learning at scale for real world humanoid robots that are deployed in the world, right? Like there's a lot of infrastructure and algorithmic challenges there. Not to mention at very large scales of models, you want to be careful that like you're absorbing intelligence as fast as you possibly can, because if your learning rate is 10x smaller than it should be, then your training run is going to cost 10 times more to make the thing intelligent.
Right.
So at very large scale models and AGI, actually the choice of algorithm that you use to soak up information is very important. It's not like an arbitrary choice. So then the question is, how do you make reinforcement learning as much of a data sponge as possible? And so that's something we're really interested in as well, is to kind of scale up our own intelligence at 1x. We collect lots of data where the autonomy fails, and so there's a big question as how we integrate that in our stack. Our Redwood model actually already trains on both successful and failed rollouts, and not in the sort of strict reinforcement learning way where it does like a like an on policy update, but it's more of like it uses the failure data to improve its representations, and that's kind of a first step towards something that's a little bit like RL, and then we'll do more and more.